Is it possible for a mathematical axiom to be right or wrong? And the answer is no, by the very definition of what an axiom is. An axiom is something we assume. So there is no right or wrong. We just assume that concept or assume that statement, and then we prove things assuming that statement. So there's no wrong or right answer about an axiom. It's just one assumption we make, and then we draw conclusions. However, if you have a set of axioms, what we call an axiomatic system, if you throw in an additional axiom, that axiom might render your axiomatic system to be inconsistent. And then you can say that that is the wrong axiom, in that you just ruined your axiomatic system. For example, you can start, let's say, define the integers. That symbol right there is the integers. So the integers can be defined axiomatically, and I define my axioms for the integers, and I define exactly what the integers are using my axioms. And now I'm going to throw one more axiom. I'm going to say that there are infinitely many twin primes. So now I would be working under the assumption that, well, the usual axioms for the integers, and I can assume that there are infinitely many twin primes. And then I can now try to prove other things using these set of axioms, where I am assuming there are infinitely many twin primes. But imagine someone comes along and shows that from the traditional set of axioms from the integers, they can prove that there are not infinitely many twin primes. Then my new axiomatic system has been proved inconsistent, because I can prove by assumption that there are infinitely many twin primes, and I can prove from the axioms also that there are not infinitely many twin primes. So the system is inconsistent, and you could say that that is a wrong axiom then to assume, because it has been proved false from the previous set of axioms. So in that sense, you can say wrong or right axioms according to whether the whole system is consistent. But in any case, due to Gödel's theorems, the whole issue of whether a system is consistent or inconsistent is a very delicate matter. So anyway, that's for another TikTok.